Hi, welcome to Shash Code. My name is Lisa Shashkova, I'm a software developer, and today I would like to present the first series on my YouTube channel, Design Buttons in Python. Why I selected this topic for recording videos about it? Well, because real-world systems are really complicated, and there are a lot of objects which we need to represent in our code base and relations between these objects. And actually, the hardest part of working on a large code base is decomposing this large complicated system into objects. It's a really hard task, and that's actually, I would say, the hardest part of the whole software development. But there are good news about it, because a lot of people before you already tried to solve very similar tasks, and they realized that there are some repeated patterns, so they were described, named, and now every software developer, experienced developer, or someone who's just starting their professional path, they can read information, learn about these design patterns, and apply them right into in their code without reinventing the same things again and again. My videos will be based on this really famous book, Design Patterns, which was written by 4 authors, so-called Gang of 4, which was published in 1994, and I think that was the book which brought popularity to the concept of design patterns in object-oriented programming languages. As you can see, this book was published a really long time ago. It happened in the previous century, but the funniest thing is that a lot of things changed, a lot of new programming languages, frameworks appeared, but there are still the same problems, very similar problems continue to appear again and again, even in the modern programming systems. So this book is pretty old, but I think it can be considered as a fundamental book. So a lot of things which I'm going to describe to you are still actual for modern software developers. Design patterns can be split into 3 main groups: creational, which describe object creations; structural, which describe class and object composition; and behavioral, which describe communication between objects. And today, in the first part of my series, I'm going to discuss creational design patterns, and 2 other groups will be shown in 2 next videos, which I'm going to record later. So, okay. As I've already said, my video is called Design Patterns in Python. So the best way to learn some architectural concepts is, of course, to look at examples. And today I'm going to show examples in Python programming language, because it has really simple syntax and easy to understand, and actually other programming languages will have very similar architecture. Okay, so we'll start with the first design pattern called Abstract Factory. This pattern provides an interface for creating families of related objects. And the most important part here is that it allows you not to specify concrete classes you are going to use during the creation. Okay, let's consider some example. We have some interface, some application with graphical user interface, and how can we implement it? Most likely, our program will have different interfaces for Windows operating system and for OS X, for Mac. And in this case, that means that we need to re-implement all our code for Windows, for Mac, and there will be a lot of code application. Of course, we don't want it. Of course, we want to extract all the duplicated code into some common code base and reuse it where it's possible. And Abstract Factory allows us to do that. For example, we will use a design partner called Abstract Factory. So here we create some class. It will be an abstract class with two abstract methods, create button and create dialog. Here we added type annotations just to better readability, but I hope you remember that abstract annotations are optional in Python. We can just need them and it won't break our program, but they just make our code more readable. Okay, and after that, so it's just some factory which creates UI elements, and now we can implement this abstract class for Windows and for Mac. We'll create Win UI Factory and Mac UI Factory. Both of them implement these methods, create button, create dialog, and both of them create objects, button and dialog. And this button button class implements abstract button interface, and abstract dialog also is the base class for both Windows dialog and Mac dialog. Okay, so here in our abstract factory, we know that these types should be returned abstract, but exact implementations exist only inside our exact implementations of our factory. So we have some abstract factory, and we have several implementations of this factory with different specifications. In our case, it is Windows UI Factory and Mac UI Factory. And why is it actually good? It is good because in our client code, so we just added implementations for these factories, but code which does some logic in our application, for example here, we can pass an abstract factory to this method and use these methods directly for the factory. So we can create button, we can create dialog, and after that we can use this method right inside our code. Click button or show dialog or do whatever we want. The coolest thing about it is that inside this check factories method, we don't know which exact factory arrived to our code. So this code will work absolutely fine with Windows factory, with Mac factory, even if we decide add another implementation for Linux application, it will work perfectly fine with the same code, and we won't need to change any single line in this code, because this code doesn't know anything about exact implementations. It knows only the fact that there is some factory. And somewhere, of course, we can check it. We can add a check for the exact operating system which user is using, and we can pass exact factories to our client code. So here, let's just run this code. If operating system is Windows, we can see we show dialog and click button on Windows. So our code was called, and we called Windows implementation. Again, if we change this code, let's check what happens in Mac. Run this file again, and we can see click on Mac and show dialog on Mac. So again, this code was executed, the exactly correct button, it was created, Mac button was created, and dialog on Mac was created, and everything was executed, absolutely fine. And that's cool. And our method check factories still doesn't know anything about exact classes, which are called here. So abstract factory is a separate class which is responsible for objects creation. Okay, let's move to the second design pattern, and that will be a builder design pattern. Builder design pattern allows us to separate a construction of complex objects from its representation. In other words, it allows us to create complex objects step by step. Again, the best way to understand some concept is to look into an example. In our case, it will be a code example. Let's consider we want to create a food builder. That will be some interface with different methods. It will be methods produce base, add meat, add main ingredients, and product. Get a result of our building process. So it allows us to create different types of food. For example, we can create pizza and we want to create soup. So we create a pizza builder and soup builder. How are we going to implement it? So product implementation will be the same for both pizza and soup. We just refresh our builder state and just build product, some result of our building process. But exact methods implementations will be different for pizza and different for the soup. In case of pizza, the product base, the most important part, is dough. So we add this item to our product state. Okay, if we want to add meat to our pizza, it will be a bacon. So we add it to our products. And main ingredients, some non-meat ingredients. In case of pizza, that will be cheese, because pizza should contain some cheese. Well, this is how we're going to build our pizza. In case if we need soup, the main product in case of soup will be water, because you can't cook soup without the water. If we need meat, we will add chicken. That's also pretty great. And the main non-meat ingredient will be just boiled vegetables, because it's soup, it should be healthy and good for your body. And now result is the class which represents the result of our food. In our case, it's just a list of strings of ingredients we added to our food. Yeah. We can even use, after that, first of all, we can use just exact builder. We can use it either directly, or we can create a separate class. In our case, it will be class Chef, and which will build products for us. So which will create builder and call exact methods of this builder class. For example, if we want to eat vegetarian food, what it means, we need to create builder and add product base there and add main ingredients, non-meat ingredients. And that's it. If we want to build some usual piece of food, a usual dish, we need to add everything, product base and main ingredients, and add meat. How will it work? You remember we have two different builders for pizza and for soup. And now let's check how it works. We created Chef, we created pizza builder, and we can, for example, build vegetarian. And now, as you remember, we had a pizza builder, so it will build as vegetarian pizza. And after that we can build soup, but we want to build usual soup, non-vegetarian, usual soup with meat. And our chef will build as non-vegetarian soup. Let's check how it works. Yeah, now we can see. So our chef built us vegetarian pizza, which has dough and cheese among its ingredients, and it also built non-vegetarian soup, which has water, vegetables, and chicken inside it. And the coolest thing is that you just need to implement existing interfaces, and all the existing client code which uses this method will automatically work with your builder. And you can combine different parts of this builder, so you can create different types of these objects. The full version of your object, the minimalistic version of your objects. You can control it with the help of your builder. So it isn't some constructor which takes 10 different arguments, or you have 10 different constructors with different arguments. It's just a separate class. Yeah, it's a separate class. It can make your code a bit more complicated, but you can control whatever you want to add to your object, or which things you want just skip and initialize them with default values. Okay, now let's move to the third design pattern. Factory method describes not the whole class as a factory, but it describes one method which can be useful, which can be added to some class, and which is very useful when you need to change an existing large code base. So users of your library, of framework, or just your code can easily reuse your code and extend your code if it's needed. Again, I suggest to consider some example today. Let's assume we want to create some file editor, some integrated development environment or something like that, just a simple text editor. We have some editor class which has a lot of different types, methods, whatever it can do with file, open file, updated text, add highlighting, add errors, a lot of things. But we know that there might be different types of documents. So there might be a text file with extension .txt, Python file with extension .py, and I don't know, HTML file and JSON file, and a lot of different types. And of course, we are starting our editor from scratch, so we can't support all the existing types of files right from the beginning, but we want to start with something. We want to add text file and Python file, but we want to have an ability for our users to extend it and to add more different types to our editor. And that's why we add this method to our file editor class, called create document, and that will be the method where we create the exact file which will be used in all other methods. So here it's an abstract method here, and we can implement it separately for text editor and separately for py file editor. Here we create text file, here we create py file. They both return type, which is, well, a subclass of document, which also has show editor. So here are different types, files, text file and py file. So again, we have text file, py file, text editor, py file editor, and editors create these types of files. And again, our client code, which doesn't know anything about exact type, it just takes editor, which was passed to it, and calls open file method. And this open file just calls show editor method. And again, we can check in some, well, there will be small part of code which checks the exact file extension. Is it .txt or .py? Let's try it. Let's try just call it. Okay, so here is txt file, and it opened show text editor. So our client code called exactly this method. Still, user opened file, still doesn't mention this text file type anywhere inside its implementation. Again, we can just change it to Py and rerun our file again, and we can see, yeah, now we opened Python editor for .py file, which is exactly correct and exactly what we needed. As you can see, in general, the main idea is very similar to Abstract Factory, which was the first design pattern. But the main difference is that Abstract Factory is a separate class which has several methods and which main purpose is to create objects. So it has factory inside its name. It just creates objects and usually doesn't do anything additional. But Abstract Factory method is just one method inside some other class, and this class may have a lot of other methods or functions and do a lot of other functionality, but it has one method which can be overridden and which allows us to extend this class. Great. We considered 3 design patterns, and now it's time to move to the 4th design pattern called prototype. Prototype design pattern allows you to create copies of existing objects, and again, your code won't depend on exact classes of these objects. You can call this so-called copy function, and it will be applicable for different types. There is no need to write it inside codebase. Actually, in Python, it's very popular design pattern, and it's even part of the Python programming language. There are actually even 2 methods for copying objects. Method copy from module copy and method deep copy from module copy. If you want to implement these functions for your custom class, you need to implement dunder copy or dunder deep copy methods inside your codebase. And after that, these functions from module copy will work perfectly well with your newly created classes. Okay, again, the best way to understand something is to look at code sample. So here's class shape. We are developing let's assume we're developing some graphical application where users can create different shapes, circles, squares, whatever they want. And here is the class of our shape. Each shape has color, that will be string. It has position, that will be, I didn't add, you can see I didn't add type annotations here, and I need to check the exact code which uses this code. So position will be a list of coordinates. In our cases, it will be 2 numbers. And actions, it will be a dictionary where key is a action name, and it's a list, for example, user's ID who did this action to this shape. Well, it's a bit unnatural, but that doesn't matter, it's just a code sample. And we want to implement dunder copy and dunder deep copy methods for our class. How are we going to use it? In case of copy, it creates a shallow copy of your object. That means that this method will copy only top level attributes of your objects. But if this attribute is also some complicated object, it won't copy its fields and its fields and its fields recursively. Now, it won't happen. The copy is just a shallow copy, so it will make a copy one on the top level copy of your object. What happens in case of deep copy? As I said, deep copy creates so-called an honest copy of our object. So even if some attribute of your object is a complicated object itself, for example, it's a dictionary which collects some also shape object which also collect some other things, some list and so on, this deep copy will go recursively through all the children of this object to the children of this object and copy all the fields of this object. That's why it has this memo argument. It's a dictionary which helps to avoid infinite recursion, because there might be some circles, and that's why it's used for remembering the exact objects which we already seen during the copy process. So in this case it's very similar, but we need to call deep copy for our position argument, deep copy for user's action, and again create new instance, reassign dictionary for our new object and return it again. Now let's see actually what's the difference. First, let's see the shallow copy. I'll just call only this thing. So we can say we created shape object with color, position and actions. We'll see it. After that we create a shape copy and try to modify its value, try to update user actions and do something like this. Okay, so we can create a shallow copy of this object and let's try to execute our file and check what's going on here. Okay, so this is how our original shape looked like. This is how it looks after we created a shallow copy and updated its values. So we updated position, the second element of our position list, and it updated in the original copy. And we also updated the list inside dictionary inside our copy, and it also was updated in the original object, which is not actually great. And now let's compare the result with the deep copy of our object. What's going on here? And you can see how it differs. So this is how the original object looked after the first one, and now we created a deep copy object and updated also position and user actions, and you can see now position list has different values and user lists also has different values inside its click attribute. So deep copy function copied not just top level attributes, it copied the object fully. So the whole copy of this list or the whole copy of this dictionary was created, and that's why updates after that in the copy object don't affect the original object, because it's a completely new object and it don't have any relations to the previous object. So that's very important thing you should remember, because many developers unfortunately forget about this difference between copy and deep copy. You should remember about it, and every time when you use design patterns, you might even didn't know about it when you called copy.copy or copy.copy, but actually you're using existing design pattern which is very famous and which is widely used in software development. Okay, that was a prototype design pattern, and now we are coming to the last design pattern for today. It's called Singleton. I think it's one of the most popular design patterns. So the main idea is Singleton is that allows you to be sure that class can that some class has just one instance and you have access to this instance. How you can reach this in your code? Class should be responsible for creating this new instance and for accessing it. In Python, there are different ways to implement it in your code base. Actually, you can create it with base class, with meta class, with decorator. I'm going to show two ways here, with a meta class and with decorator, but there is also other ways. They might be different for different programming languages, but again, we are not discussing a syntax here, we're discussing the main idea behind this design pattern. So what's going on here? We're describing a meta class, Singleton meta class, which overrides dunder call method. So when someone wants to call constructor for our class, that's actually a dunder call method, it will be called. What happens after that? After that, we check if we already have this class if we already have instance for this class which was passed as an argument. If we don't have it, we create instance of this class, store it inside our collection, and return it as a result of this call method. If this class has already been created, if user called constructor a second or for the third time, we by default return it from our existing collection. So actually this meta class can work with many different classes. It just has just one big collection, one dictionary for storing all the instances inside our collection. Something similar to the Singleton decorator. So again, we have a class, we store instances, dictionary here, and again, every time this method is called, we're checking if it has been called for this class previously. If not, we create new instance. If it has already been called, we just return the instance which is stored inside our dictionary. Let's run this code and check what's going on here. Yeah, so here we created Singleton class with meta class, and we compare identifiers for these objects. They are the same, so that means it's the same object. And again, Singleton decorator class, again we compare identifiers, and they are also the same. The main idea, as I already said, is to be sure that only one instance of this class was created, and you actually have access to this instance from almost any point of your program. Of course, there are some problems with this pattern because it can make your code more difficult for decomposition, because you have just one class and you call it in several places, and once you want to split your code base into several subsystems, but they all use the same singleton, so it will be more complicated process. Yeah, that's not good, but still it is very useful and it has a lot of advantages, and a lot of developers use it in their systems. So today we discussed the first group of design patterns which can be used in software development, creational design patterns. These design patterns allow us not to create objects directly by calling constructor, but allow us some existing templates or solutions if we want to create groups of similar objects, or we want to have ability to extend our objects, or we want to have just one instance of some class and do a lot of different things. Again, I want to emphasize it one more time. Although all the examples here were in Python, the exact programming language or its syntax doesn't really important here, because the main idea behind design patterns is to describe the architecture solution, architecture idea, and actually you can re-implement the same idea in different programming languages. And it doesn't matter which exact language you're using in your job or inside your pet project. The main thing here is that you can use it right now. Of course, some patterns are more popular, some patterns are less popular. Of course, there are different systems with existing architecture, and if you know some pattern, it isn't necessary to apply it right just because you know it. No, of course, every time when you use some pattern, you should clearly understand why you're using it here, which advantages it will bring to your exact code base, to your exact use case. I hope you liked today's videos. I want to remember one more time, it was just the first episode of our series. In the next video, we are going to look into structural design patterns, which will be even more fun, I think, than creational patterns. So don't forget to subscribe to the channel so you won't miss the next video. And of course, I will be happy if you put some like to this video, or of course don't forget to ask your questions and leave your comments, because it's also very important. There might be some blind spots in my description and my explanation, so it's better to ask it and to discuss it with me or with some other users. Thank you very much for joining us today. I hope you had fun during watching this video, and see you in the next video. Bye!